I would like to focus on here is a very, very simple story. So if we look at Arctic sea ice in the past, so this is a picture from 1979, we find that in the past the entire Arctic Ocean in summer was covered by sea ice, this floating frozen seawater that we see here. Now, this is about 35 years ago. If we look into the more recent past, 2012, the area of the sea ice in the Arctic we have in summer is roughly shrunk by 50%. Also the thickness has shrunk by 50%. And while I don't want to do complicated math this early in the morning, if you halve the area and you halve the thickness, that means that over the past 30 years, we've lost roughly 3/4 of Arctic summer sea ice. And so the question then naturally arises as to when we will have reached a state where the Arctic sea ice is gone in summer, or you have an ocean in the Arctic that looks like any other ocean. Just water, nothing special about it. And I could talk lengthy on all the impacts that this will have on climate, on society, on polar bears, on animals, on shipping routes. But I would here just like to focus on one thing that I myself care much about. If I go to the Arctic now, and if we could get the next slide please, and I take photos there, and I go home and show those photos to my kids, it feels a bit odd to know that once they have reached my age, this landscape will be gone possibly. And so we are looking there at an entire landscape vanishing in front of our eyes. And what we scientists try to understand at the moment as to whether we can still stop this complete vanishing and what we can have to do in order to stop the vanishing. And now if we look at the model simulations we've used, for example, for the last IPCC report, it's very difficult to say what the future will bring because those model simulations are all over. And so what we've tried to do in the past year or so is to try and extract from all these model simulations some very robust physical relationships. And one is shown here that for all these model simulations, the amount of sea ice we have in the Arctic is almost linearly related to the amount of CO2 we have in the atmosphere. So this is a very, very simple relationship we get from all the model simulations we have available today. And now the amazing thing is that we see exactly the same relationship also in the observations. The amount of sea ice we have in the Arctic over the past 50 years or so is absolutely linearly related to the amount of CO2 we have in the atmosphere. And we've just put in a paper where we show that this robust relationship, this linear relationship also will hold in the future. And so we can basically just extrapolate the evolution of Arctic sea ice into the future. And it turns out that roughly at the CO2 concentration, probably below 500 ppm, Arctic summer sea ice will be gone. And this 500 ppm is well below anything that we have currently in all the indices that have been put in. And if we can get the next 3 slides, just 2 more. And so just to summarize this, the future evolution of Arctic sea ice really depends directly on future CO2 emissions. At current emission rates, Arctic summer sea ice is likely gone by mid-century, and current indices are not sufficient to allow Arctic summer sea ice to survive. Thank you very much.
Thank you, everyone. I think we have time for maybe one question, but otherwise, certainly the scientists will be available to answer additional questions outside. Yes, please.
Hello, Erik from Dublin Radio Deutschland. The carbon which is released from permafrost, is it in form of methane or of CO2, or both?
It'll be in the form of carbon dioxide and methane. And the challenge right now is figuring out how much will be released as carbon dioxide and how much will be released as methane. One of the challenges there is when permafrost thaws, it changes the landscape, so you get ground slumping. So areas that are dry now may be wet tomorrow, leading to a release of methane, and vice versa.